Welcome to this week's episode of Basics of Programming. This episode will be on logic in Java, focusing on the if statement and how to properly use it. As always, the video will be divided into two sections, essential knowledge and additional information. Feel free to skip ahead to section 2 if you already understand the basics of logic in Java. With that out of the way, let's begin. Part 1. Essential knowledge on logic in Java. First off, what are logical operators? Logical operators are certain operators, or symbols that perform an action on a value, that can change the flow of code. In particular, logical operators can be used with the if statement to perform different actions depending on a condition. If statements are passed a condition and enter a block of code only if that condition is true. To form these conditions, we use the logical operators, which include and, or, not, and XOR. In addition to these, we can use mathematical comparisons, such as equals equals, more than, more than equals, and less than equals. You may have noticed a repetition of and, or, and equals equals. The first two we will talk about in section 2, and the last is repeat to distinguish setting a variable to a value, comparing it to that value. When using a logical operator, it turns the statement into a Boolean value, which is either true or false. As a result, you can set the value of a variable to a statement using these operators, and because an if statement takes in a Boolean, you can pass a Boolean variable into an if statement, and it will enter the block if the variable is true. Next, let's go more in depth with if and else. An example of these can be seen to the right, where a condition is passed in the parentheses of an if statement, and the code between the curly brackets is a block which is run only when the condition is true. Along with the if statement, we can use the else statement, which runs a block of code only when an if statement is false. This makes sure that we never enter both blocks, and at the same time we are never forced to write another if statement covering the opposite case from the previous if statement. Else can only be used right after if, as it will always revert to the previous if statement. Else statements are especially useful in chains of logic, where the programmer only wants to enter one block of code. Using else statements saves you from having to check for the opposite case for every previous if statement, and when used alongside an if in a form that's known as an else if, this saves a lot of code from being written. Else ifs are so important to logic that some languages created a separate statement for them, such as Python's elif. Now let's take a closer look at operators. There are two types of logical operators, those that take booleans as input and those that take other variables as input. Both categories can be used in between two comparable variables of certain types. For example, to use and you'd write the first boolean variable, then then the second boolean variable. These operators are very clear given their names, but let's go over each one. And, also called conditional and, is true if both values are true. Or, also called conditional or, is true if either value is true. Not goes before a single boolean and makes the statement equal to the opposite of that boolean's value. And XOR is true if exactly one value is true. More than is true if the first number is greater than the second. Less than is true if the first number is less. Equals is true if the two numbers are equal. And more than equals to is true if the first is more than or equal to the second, with less than equal to being true if the first is less than or equal to the second. Now I move on to part 2, additional information on logic in Java. Let's go a bit more in depth on what we talked about before. Like hinted to previously, and or are valid syntax in Java, but they are usually outclassed by and or. This is because and or stop when their condition is met. As in when an and sees a false statement or an or sees a true one, it does not bother checking the second condition. This is known as short-circuiting and is very useful, especially to avoid errors. In particular, calling a method on an uninitialized object causes an error known as a null pointer exception. Adding the statement variable is not equal to null before the condition and using an and makes the program drop out of the condition when the variable is null, preventing this error from occurring. Another useful structure is the switch case, used to avoid long chains of if, and else when checking the value of a single variable. In these, you pass the switch statement as single variable, such as input above, then give it cases or potential values for that variable, with a block of code for each case. Switch cases also have a default case, which acts as the last else in an if, else chain, and catches any other cases. When using switch cases, remember to use break at the end of each case, as it will otherwise enter every following block, even though it does not fulfill that case. Finally, let's talk about branching and the ternary operator. When code is run, the CPU usually divides it between processors in something known as a pipeline architecture. This is very efficient in most cases due to the linearity of code, but causes issues with branching statements. When a processor reads an if statement, it may not know whether to enter that statement, and as a result, it stalls until another processor catches up so it gains that information. This causes a drop in performance, albeit a negligible one in most cases. Statements that cause this are known as branching statements and are most notable if and else. As a brief aside, smart processors will often compile branching statements in a way that does not branch when it converts it down to assembly or computer code. But in many cases, this is impossible for a computer to do while keeping the code functionally the same. Java also has ternary operators, which are also branching statements, but are much easier for a computer to compile into a linear set of instructions than an if statement, and as a result, more often going to be more efficient. They also simplify many use cases for an if statement, as with two symbols and a condition, they can choose one of two variables to give the value of. The example to the right shows the structure, which is a condition, then a question mark, then the true case, followed by a colon in the false case. And with that, today's episode comes to an end. Feel free to leave comments below. I would love to see what you thought about the episode or any feedback on the format, and if you have any topics you would like to learn, please let me know below. Next week's episode will focus on loops. Thank you for watching, and I hope this video helped you better understand logic in Java.